Okay, today we're going over rationalizing expressions. When you rationalize an expression, as the name shows, you're basically just making that expression rational. And the way you're going to make something rational, or put it in simplest radical form, is something in simplest radical form. Let me just write that down. Something in simplest radical form has a rationalized denominator. Rationalized denominator. So anything you see that has a rational denominator, so let's say you had y over x. If x is rational, then this fraction is going to be rational. So just remember that anything that's rationalized or in simplest radical form has, I forgot to put the m here. Form has a rationalized denominator. Okay, so let's say we have something like 1 over square root 3. Now, square root 3 is, it's a square root, right? So it's not, this fraction is not rationalized. So the way we're going to rationalize it is that we're going to multiply the top and bottom by square root 3. So we're going to do multiply it by square root 3 over square root 3. Because square root 3 over square root 3 is essentially 1, right? So we aren't changing the expression at all. We're just multiplying it by 1. So what's important to know from this is that if you have a fraction and you want to rationalize it, you're going to multiply the top and bottom by the square root you want to get rid of. So if you have a square root as your denominator, multiply the top and the bottom by that square root, and you'll eventually get rid of it. So let's do 1 times square root 3, that's square root 3. And then square root 3 times square root 3 is square root 9. And I know square root 9 is still a square root, but square root 3 stays square root 3, but square root 9 is just 3, right? So now we have square root 3 over 3, and this, let me just erase this. This is the same thing as this, it's just rationalized. So that's what you're going to do if you have a fraction that's not rationalized. Now let's do another one. Let's say we had 3 over the square root of, now let's do 5. Okay, 3 over the square root of 5. So like I said before, we're just going to multiply this by the square root of 5 over the square root of 5, which is just 1. And then 3 times the square root of 5 is 3 square root of 5. And then the square root of 5 times the square root of 5 is the square root of 25, square root of 25. The square root of 25 is just 5. So we have the 3 square root 5 over 5. Now let's do one more. Let's say I had the square root of 3 over 5 times the square root of 8. Now I know there's a 5 down here, but we're still going to do the same thing. We're just going to multiply this by square root of 8 over the square root of 8. And then over here, we'd get the square root of 24. And over here, we'd get 5 times the square root of 64. Now, there's 2 things that can be changed. One is the square root of 64, which obviously just becomes 8. And 2 is this square root of 24 right here, because that can be rationalized or simplified. We can put, here I'm drawing this sideways. Let's just say I had an 8 and a 3, and then a 2, 2, 2. So that's a 2 pair, and then a 3 and a 2 left out by itself, right? So the square root 24 becomes 2 times the square root of 6, and then the square root of 64 is 8, right? So 5 times 8 is 40. Now, this could be our final answer, but you might notice that 2 over 40 can be simplified because 2 over 40 can become 1 over 20. So let's actually change this to 1 over 20 and just have our final answer as square root 6 over 20 because we just simplified it. So here, let me just make this a bit neater. Square root 6 over 20. And that's going to be our final answer. Okay, now let's move on to something else. Let's say we had the square root of 1/4. We were given just the square root, and then the fraction 1/4 was inside of this. Square root of 1/4. Now, what's interesting is that whenever you have a fraction inside of the square root, you can separate, you can almost say separate or put the square root on both the numerator and the denominator. So the square root of 1/4 could become the square root of 1 over the square root of 4. So if you have a fraction inside of that square root, it's the same thing as if you just put the square root both on the top and on the bottom. And so a situation like the square root of 1/4, it would be the square root of 1 over the square root of 4. Now, the square root of 1 is just 1, because 1 times 1 is 1. Then the square root of 4 is just 2. So we've rationalized this and rationalize this expression. So the square root of 1/4 is equal to 1/2. Okay, now let's say we have something like the square root of 16 over 3. We do the same thing, so the square root of 16 over 3 would become the square root of 16 over the square root of 3. The square root of 16 is 4. And the square root of 3, let's just keep that there. Now, this isn't rationalized, right? Because there's still a square root or a radical at the bottom. So we're going to do what we were doing earlier in this video, which is multiply the 4 over square root 3. Let me put it down here. By square root 3 over square root 3. So we'd get 4 square root 3 over the square root of 9. And the square root of 9 is equal to 3. So we just have 4 of square root 3 over 3 as our answer, because 4 over 3 cannot be simplified anymore, so that would just be our final answer. Okay, so now let's move on to rationalizing expressions, but with cube roots instead of square roots. So let's say we had something like 1 over the cube root of 7. Now, we have a cube root on the bottom, so we do the same thing that we did with square roots, so we just multiply this by cube root of 7 over the cube root of 7, which is still 1, and then we get the cube root of 7 over the cube root of 49. Now, if you notice here, I still have a radical right here, so this isn't rationalized, and you might think we can't do anything with the cube root of 49, right? If we could do something with the square root of 49, because that's 7, but not with the cube root. With the cube root, we're going to need 3 pairs of 7, and right now we only have 2, 7 times 7. So what we need is a third 7, so we can change this cube root into 7, but right now we can't. So we need this third 7 right here. Now the way we're going to add that third 7, so we're actually going to multiply this, the cube root of 7 over the cube root of 49. by the cube root of 7 over 7, which, like I said before, is still 1, because that's going to give us that extra 7 that we need, right? So this would just become the cube root of 49. But this would become the cube root of 49 times 7, which is the same thing as the cube root of 7 times 7 times 7. Now, the cube root of 7 times 7 times 7 is, of course, just 7, right? So we can just change this into a 7. And just like that, we've rationalized this right here, simplified this into this. And that's how you would do it if you had a cube root. Now, let's do a couple more, 2 more. Let's say we had a problem like 1 over the cube root of 11, and we needed to rationalize this. Now, we could do the same thing. We could do the cube root 11 over the cube root of 11. Yeah, that would work, but we'd eventually, later in the problem, have to add that third 11. Because if you notice, to change the cube root of 11, oh, wait, I messed up there. The cube root of 11 into 11, right? To change this cube root of 11 into 11, we're going to need 3 pairs of 11s. We're going to need an 11 times 11 times 11. And if we're only multiplying this by the cube root of 11, then we're only getting 2 pairs of 11. We'll only have the cube root of 11 times 11. Well, we need that third 11. So what can we actually do to make the problem a bit faster is that we would multiply this. We would multiply the 1 over the cube root of 11 by the cube root of 11 times 11, which is still 1. And that way we get that pair of 3 11s. Now, if you had a fourth root of 11, we'd need 4 11s, right? So we'd multiply it by 3 11s to get that fourth 11, right? So just like what you did with the cube root, if you had any other number, any higher number, you would just multiply it by the number of 11s that you need to get, to simplify that radical, which is on the bottom. So we multiply this by 11 times 11 to get those 3 11s at the bottom, which will make our 11. So this becomes the cube root of 121, and this becomes the cube root of 11 times 11 times 11, right? Which is basically just 11. And yeah, so that's going to be our final answer, right? That's how we're going to rationalize expressions with cube. Okay, let's do one more problem. Let's say we had the cube root of 27 over 4. Now we can do what we did with the square roots. We can do the cube root of 27 over the cube root of 4. The cube root of 27 is 3. So we have 3 over the cube root of 4 right here. Now, the cube root of 4 is still a radical, right? So it's not rationalized. The expression isn't rationalized. So we're going to, like we did with the last 2 problems, we're going to need to add those 2 more 4s to turn that cube root of 4 into a 4 by itself to rationalize this expression. So let's multiply the 3 over the cube root of 4 by the cube root of 4 times 4. Cube root of 4 times 4. That would get us 3 times the cube root of 16 over the cube root of 4 times 4 times 4. And that's just 4, right? So you have 3 times the cube root of 16 over 4. Now, this is rationalized, but if you notice that square root of 16 can be simplified, right? Because the square root of 16 becomes 4 times 4, which becomes 2 times 2 times 2 times 2, and then we have a trio of 2's and a 2 by itself. So that's cube root of 16. Here, let me just erase this here, just to give me a bit more room. That cube root of 16 becomes 2 times the cube root of 2, right? And then if we put that in place of the cube root of 16, 3 times 2 times the cube root of 2, we get 6 times the cube root of 2, right? So we simplified that cube root 16, and this is got to be our final answer. No. Sorry, I just realized I made a mistake, guys. I hope you noticed what I forgot to. This 6 over 4 right here, this can be simplified. So we can change that 6 over 4 into 3 over 2, right? And let's make sure not to forget the cube root of 2. Now this is our final answer. So that just be a lesson to always double check your work to make sure that you didn't forget something like I did. Okay, thanks so much for watching. I hope to see you in the next video, and see you tomorrow, I guess. Bye-bye.